Okay, we're going to sketch the orthographic view of the given object on the grid provided using the third angle projection. So for third angle projection, please be reminded that this would be your top view. This would be your front view. And this is going to be your side view. Now we're going to draw. Before we're drawing, if you are not given the dimension, just look at the grid given. First of all, we need to make sure we can look and imagine the base box. So what is a base box? We are going to imagine that we're going to look at this orthographic view as if this object stays in a box. For an example, if you look at this question, let's say we're going to draw the base box. The base box would give us an idea on the view that we're going to project from top, front or side view. For example, okay, this is the height of the object. So this is going to be the height of the object, and this is going to be the width of the object. Okay, it shouldn't be inclined, it should be straight. So just let me draw that again. Okay, I'll just use into shape. Okay, then I'll try to make it straight as possible. Okay, I made it this way. This means this is where we're going to look from to view the object from this side. So we're only going to look at this square. Whatever we see from this side, that is the projected view for front view. Now it's the same thing. Okay, now I draw it in a wrong manner, but I hope you can see that I'm trying to draw a box here. Okay, this is to represent the side view, and this is to represent the top view. Now if you look at it, inside, outside, this blue line shows that it can be seen as if it's a box. This is what we call as base box. Now what is a base box? It's a box where we are going to imagine all our objects stays inside the base box, and this would be easier for us to draw for each projection. Top view, front view or side view. Okay, now if you can look at the base box for any question, if you can imagine the base box, it will be easier for you to understand how the projected object would work. Or you can imagine, if let's say you can't imagine the base box, it doesn't matter, but you would have to, another way to understand orthographic projection other than drawing the base box would be to annotate each and every corner. Okay, I'm going to use the same question and show you. If we were to use the same box instead of using base box, let's see if we can just annotate each side. Now annotating each side would also need the base box, because it will exactly show us how we're gonna represent our answer in the 2D orthographic projection. For example, if this is the top view, do you know where does this point is in the original object? That is what we're gonna do. Now for example, if I were to annotate, I can say that this is point 1. Okay, wait. Okay, I can say that this is point 1. Let's say this is point 2. I can label according to whatever you want to label. So from here, we're going to label each and every point. 3, this is going to be 4, this is going to be 5, 6, 7, 8. This point here, I'm going to smaller pen. Okay, this is going to be 9. This point here is going to be 10. This is going to be 11. This is going to be 12. This is going to be 13. Whatever point that you are labeling or annotating here is only the visible point. If you cannot see the point below here, you don't label it. It means you cannot see it. So here it's going to be 15. I'll label this as 16. I'll label this as 17. So I'm gonna try to show you this method instead of using the base box. We can also actually label the base box, keep the number for the base box, or you can also do it this way. For example, we're trying to draw, we would always start from any one view that is easier for you. Now for your question, please bear in mind that it will be easier for you if you draw a cross before drawing, because we need to project each and every line. By projecting, it will be easier for you to look at each question. Yeah, it will be easier for you to project a 45 degree. This is a 45 degree line, so it will be easier for you to project each and every point here. Okay, now let's look at the top view. If I were to start from the top view or from the front view, it is okay. Let's say we're looking from the front view. Since the answer is already here, I'm only going to show you where are these numbers in this answer. Okay, if this is the front view, so for the front view, let's look at this point. Where is this point? This point is actually number 17. Okay, this is going to be number 17. Okay, if you look up, go straight from here. This is point 1. Okay, then go straight this side. This is point 16. If you look, actually this point 16 is on the same line as 3, so you can stroke 3 here. So 1 can be stroke 2 because it's the same line. Even though the point 2 is behind, so we know that it's actually standing at the same point. Selari dengan nombor 1 dan nombor 2 ini selari yang berada pada level yang sama. Dia bukanlah nombor 2 tu lagi tinggi daripada 1 atau 1 tu lagi rendah daripada 2, tetap. This, by drawing, by giving this kind of annotation, kita nak pastikan, kita tahu bahawa this point 1 and point 2 berada pada satu jalan yang sama, pada satu line yang sama. It's the same thing for 16 stroke 3. Why for 17 tak ada? Sebab we cannot see the point behind. Number 4 is not on the same line as number 17. Okay, so I hope you understand that point. So if you go here, we're looking for front view. After 16, we go down, we can see point 15. This would be point 15. Oh, I need to make it bigger for you so that you'll be able to see. Okay, now maybe you'll be able to see it better. So from 16 is 15 here. I can see 15 and 4 are on the same line, so you can stroke 15, stroke 4. And this point here is 13, stroke 12. This point here is going to be 9, stroke 11. This is 10, stroke 5. So if we go down from here, go down, this is 7. 7 on the same line as 6. There we got 8. And this is 14. Now, why am I writing this number? This is just the label and annotation saying that we understand we are actually transferring the isometric drawing into orthographic view projection. Now, what we can do is we can use this number to assist us to draw the other views. For example, if I were to draw the right hand side, I would be looking from this side. Okay, this is going to be my side view. Okay, this is going to be my side view. So if I were to look from this side, what I can see is 7. So number 7 that I have written here must be on the same line when I were to project to the other view. Okay, so if 7 is here, so 7 must be here, or it must be on this line. It cannot be here. If for your front view your 7 is here, and suddenly for your side view your 7 is here, means your projection is wrong. Your view of your projection is wrong. Okay, now that we're looking at it, see. Okay, so we will look from here. So this point 7 is here. So 7 actually on the same line as 8. So yeah, oh yeah, correct. This is 8. So same line as 14, same line as 17. Do we have to write 14 and 17? No, we're only going to write 7 and 8. Because there's a gap between 7 and 8. If we were to write, I don't think it's a problem as well. Okay, now as we go along, if we go up from 7, this is number 10. Okay, I'm going to ignore the cross numbers behind. Okay, just write 9. So if we go from this side, 9, 13, 15. Can you see 15? Yes, 15, 13, 9 and 10 are on the same line. Since I don't have any space here, I'm not going to write. But I assume you would know. So as we go along from this side, when you look from this side, you could also see this part. You can see this part. You can also see this part. Bear in mind that behind this part, there's a hidden block here. There's a hidden block here. Now, there's a hidden block, but you cannot see that block. You know there's a hidden. You just have to make sure that when you draw your points, this is actually behind. This is just point, which is behind the side view, but we need to label it as such line, dotted line, to indicate that that is a hidden part. Okay. Okay, now let's just label the other numbers. So this is actually point 16/1. Okay, so because 1 is behind, this would be 3/2. This is actually 5/4. 5/4. This would be 6. Okay, now we're to project. Does all the number align in the same point? If it does, yes, then you are at the correct. You're just using this number to check whether you are at the right. You're doing it correctly. Even if it doesn't matter, you don't have to edit any of it. You could just straight away draw. It doesn't matter. Okay. Okay. So from here, from top. Okay. Let's say if you don't want to label each and everything, what we can do is we can project all the lines that are involved in one view to help us to draw the other view. Okay. Now, let's see if I were to, I do not want to label any of this. If I do not want to label any of this, what I would do is, for my line just we have it there. Let's see. Okay, we're going to project. So I'm going to use a pencil and try to project. Let's try to project each and every line. You have to project. Let's say you started from the front, so you have to project this line further up. Now I can see it's very thin line. It should be very thin. I'm trying to do it manually, so just bear with me. Okay, so just draw it. Just project each line. I'm just doing it manually, but I hope you get the idea. You have to project each and every point. So you're going to project. You're going to project using construction line. So here, you're going to have to use. It has to be same. So you're going to connect it 45 degrees. It has to work all together. Now you have it. Okay, it's either you project it this way or you just have to label. You choose either you want to label this. You can actually label the whole object just like that, just by putting numbers, or if you feel like you need a base box for you to look, then you can draw a base box. As I've said, what is a base box? Base box is a representation saying that our object stays inside the box and we're looking from each and every side. Okay, I'll draw and I'll try to draw and show you a base box. This would be our object, and let's say we need a base box. Okay, let's draw a base box. Your base box, the height and the width must be the same as your object. This is the width, so your base box must have the same width and must have the same height. You're not drawing a base box bigger than your object. We're drawing exactly using the same height and width. Okay. this height must be the highest point. Okay, it has to follow the highest point. Okay, so this is an example of this. If you see, if you were to compare, this is actually the view if you were to look from the side, and this is going to be the view from this side. If you were to look it from the top, this is going to be the view. Let me show you with different colors. If you were to see from top, you can actually see this square here. Then if you were to do it, look from the front, this is where you're going to imagine you're going to look from this square and see. What can you see? Only those part that you can see will be drawn. Apa yang